So welcome again to another session of trigonometrical functions. Still looking at the MIT 2023 Integration B regular season. And today we're looking at question number 8, which is the integral of x sine to the power of 4 of x from 0 to pi. Now, before I begin, I'd like to encourage those of you who are here for the first time or for a second time but haven't subscribed to subscribe to our channel. Here, we look at numbers. We try to get to the bottom of them by, proposing some solutions. So for this problem, what I'll do is first I will expand the sine to the power 4x, and so we have sine squared x and sine squared x. Now, for those of you who know that cos of 2x is equals to 1 minus 2 sine squared x, sine squared x. What essentially this means is that when we make sine squared x the subject, we have 1 minus cosine 2x divided by these 2 on the right hand side. So when we replace that in this equation here, so we have x times 1 minus cosine 2x over 2 squared. And then you pull the 1 over 2 squared out and you have a quarter. And then inside the integral sign, now we have x 1 minus 2 cosine 2x plus cosine squared 2x. So we have a quarter because now we can separate these terms and try to integrate them separately. And so we have a quarter of the integral of x from 0 to pi, and then we have now 2 over 4 x cosine 2x, and then we have a quarter of x cosine squared 2x. Now we have 3 separate integrals. We have demarcated them as blue, green, and purple. And so for our blue integral, that's as simple as a quarter times x squared over 2, and then with the limit 0 to pi, and that gives us the answer of pi squared over 8. For our green integral, now that we would have to use integration by parts, and so 2 over 4, which is the same as a half, times, and the expression here cosine 2x is the same as the derivative of half of sine 2x. So we can express it this way, so that the first point we can now say the product of the non-differentiated terms, which is x times a half of sine 2x, which we have here, 0 to pi minus a quarter of now dx dx, and so that becomes 1 times now half of sine 2x, keeping this half also there, so we have minus a quarter of sine 2x integral. So when we now try to solve for this, at the upper limit we have pi sine of 2 pi, pi times sine of 2 pi, sine 2 pi is 0, so this entire time goes to 0. In the lower limit we have 0, sine 0, so this is 0, so this entire term is 0. Now we're left with a quarter minus a quarter integral of sine 2x, which is the same as negative a quarter minus cosine of 2x here. And so when you solve for that, we have this half going out and this becoming a minus 1 over 8, and then we begin, because of the negative sign, we can flip the sign, cosine 0 minus cosine 2 pi, cosine 0 is 1, cosine 2 pi is 1, 1 minus 1 is 0, So this entire term is 0. Now going on to the purple integral, with the purple here, we have to express this cosine 2x, cosine squared 2x into the value, an expression that does not involve powers. So we have x, and again using the expression of cosine 4x is equals to 2 cosine squared 2x plus 1, making cosine squared 2x the subject, results into what we have here. And so we can pull 1 over 2 out so that we have 1 over 8 integral of x times 1 plus cosine 2x. Okay, so it's the same as the integral of 1 over 8 x from 0 to pi, and the second term can also be integrated separately, which is 1 over 8 cosine 4x. So looking at the first term there, which is the same as 1 over 8 times x squared over 2 from 0 to pi, and that results into pi squared over 16. Going into the second term, trying to integrate this, what happens is that 1 over 8 times the integral of x cosine 4x, the same as 1 over 8x, the derivative of 1 over 4 sine 4x. And so using again integration of by parts, we have now 8 times the product of the non-differentiated terms, which is quarter times x times sine 2x, minus, now on this second side here, now we can pull this constant 1 over 8 times a quarter dx, which is 1 sine 4x. Now solving for this first part here by substituting the limits, the same as 1 over 32 pi sine 2 pi minus, and so this is, sorry, sine 4 and sine 4x sine 4 pi here, and this entire term goes to 0 because sine 4 pi is 0, and the lower limit 0 sine 0 is 0, and then we are left with now the negative of 1 over 32 integral of sine 4 x, and again that now results into 0 minus 1 over 32 times 1 over 4 cosine 4x from 0 to pi, and when you substitute the limits in there, because of this negative sign, we begin with cosine 0 minus cosine 4 pi. This is cosine 0 is 1, cosine 4 pi is 1, and this entire term becomes 0. So essentially now we have the integral of x sine 4 the power 4x being equal to the 3 independent integral. From the first integral we had pi squared over 8. From the second integral we had 0. From the fourth integral, it got split into two integrals. The first part of the integral was pi squared over 16. Second part was 0. So the answer here now is, adding these two terms, 3 pi squared over 16. And so this is the answer. Not very complicated, but as we end, a quick shout out to our subscribers. Thank you so much for being with us. We don't take it for granted. And for those of you who haven't subscribed, again, my humble plea, please subscribe. The more you guys subscribe, the more traffic we'll get, and that will give us that extra visibility. Again, thank you for being with us. Until the next video.